Now we are going to compare various types of programmable logic devices. So first one is the programmable ROM, that short form is the PROM. So here we have first fixed and array, that also we can design with the help of decoder. And second part we have programmable or array. And in case of PLA, both sections are programmable. That is, we have programmable and array as well. We have programmable or array. Whereas in case of PAL, we have only programmable and array, and we have fixed or array. So this is the basic difference between PROM, PLA, and PAL in terms of design. So when we are going to design for the particular Boolean functions, in that time we need to take care of this. Next, we are going to see how to design the programmable ROM for the given Boolean functions. So here I have considered two functions f1 and f2. Those are the four variables. And we know that in case of PROM, first block, what we have first section, that we have a fixed and array, so that we can design with the help of decoder. And second part, we have programmable or array. So first we'll see how to design PROM with the help of decoder, and later we are going to see how to design PROM with AND array also. So size of the decoder, here we are going to choose on the basis of input variables. Since here we have 4 input variables, so that's why we'll have 4 inputs to the decoder. So since 4 inputs we have to the decoder, so it will generate 2 to the power 4 means 16 outputs. So we are going to get the 16 outputs. So decoder size is 4 cross 16. So here A, B, C, D are the 4 variables. Those are going to become input here. And here we have outputs that is marked from the 0 to 15. Since in the binary always we start with 0 in case of digital electronics. So this 16 outputs are marked from 0 to 15. Now it's easy to design with the help of decoders. Now first we are going to, so again here we have to decide how many OR gates are required. So how many Boolean functions are there, that much will be the number of OR gates. So here I have chosen two functions, f1 and f2. So that's why we require 2 OR gates. So before design, we should decide what will be the size of the decoder and how many OR gates are required. For the connection of the OR gate, we are going to take the logic of the logic array. So where we are seeing that with the help of single lines, we are able to represent the multiple inputs with the concept of fuse intact and fuse belong. Wherever we are going to mark the cross, it will show that fuse is intact. So when fuse is intact means it has one state, and where we have plus sign means horizontal and vertical lines are crossing each other, it shows that fuse is blown. So when fuse is blown means it is in 0 state. So now first we'll see for the function f1. So that mean terms, what are the mean terms are given, corresponding decoder pins we are going to mark with cross. So for the function f1, we have first mean term is 0. So here we'll have cross. Next second is 1. So again here we have cross. Next mean term we have 2. So for the 2 also we are going to put the cross. Next we have 3. So for the 3 also, so here consecutive mean terms are given. Next we have 6. So for the 6 we have cross. Again we have here 9. So for the 9 also we are going to mark the cross on this line. Again we have 11. So for that 11 also we'll mark the cross. Like this we have marked the, for the function f1, whatever connection is possible. that is connected with the decoder's output. Next, we are going to see for the function f2. So function f2 also have 0. So that 0 output of that connected here to the f2. Next is 1. So at 1 we are going to put the cross. Next we have 6. So at 6 also it will be cross. And next we have 8. So at 8 we have to mark with cross. And last one is the 9. So at 9 we are going to mark again with cross. So how many mean terms are there that we can count from here, that corresponding mean terms are marked here or not. So now we have function f1 and function f2 that is being represented here with the help of decoders. If we are interested, we can simplify again later this one with the help of AND gate, or here we can go for the K-map also. After getting the K-map, later if you see that we are going to discuss there with the help of K-map. So again, we'll obtain the Boolean function there with the help of K-map. So on the basis of that, again, we can see the combination of the decoder output also. Likewise, here we have output is A dash, B dash. Suppose one product term is here, A dash, B dash. So that we can analyze how we are able to obtain these combinations. So for that purpose, we can have different combinations that also we can realize. Now we are going to see here that PROM with the help of AND array. So since first block what we have fixed AND array, so that concept we are going to use here. So now how many inputs we have? Since we have 4 variables, so that 4 variables A, B, C, D. So for that we have to perform the K-map operation. So this K-map is for the function f1 and another K-map is for the function f2. So like this we are able to make the K-map. Since here we have 4 variables, so 16 boxes are required. So that is marked here. A, B, C, D are the inputs, and we know how to mark these literals one at a time. Only one bit should change. On the basis of that we are marked, and inside boxes are also numbered on the basis of literals. So already I have marked the whatever mean terms are given for the function f1. So now we have to make the combination. So here if you see that first row having 4 adjacent square boxes. So this is going to give us the product terms. So row wise here common is A dash, B dash, whereas column wise will not get anything common. Second combination we are going to make here with the help of 9 and 11 mean terms, and here we have 1 and 3 mean terms. So from here if you see that row wise we have common, that is B dash, and column wise you have common, that is the D. So another product term we got B dash D. Now one literal is left here. So for that we can make the again combinations. So that combination is here. Pair is possible for this. So this pair equivalent row wise common is here A dash, and column wise common is C and D dash. Only one column is here. So we have this literals. When we have combination of 4, we are getting 2 literals. If suppose we have combination of 8, we'll get 1 literal. Combination of 2, we are getting 3 literals. So finally, this is the f1. That function is A dash B dash plus B dash D plus A dash C D dash. Similarly, we can go for the function f2. So here we have symmetricity, this combination with the help of 8, 9 mean terms and 0, 1. So it is again going to form the quad. So here if you see that what is the row wise common? So row wise common is what we have B dash, and column wise common is what C dash. And this one is the isolated here. So for this, we'll get the 4 literals. So row wise, you have A dash B, and column wise, we have C D dash. So now for the function F2, we have 2 product terms. Now it is time to implement this given Boolean function. So already we got as the sum of products. So those things we are going to represent here. So we have 4 inputs. So that inputs we are going to mark here A, B, C, D. And we are using the buffer here to obtain the output with complement and without complement. Where bubbles are connected, that is going to give the output with complement. Without bubbles, we are connecting, that is without complement. So like this, we have to mark the input section. So now in the bottom also, if you see that we have marked here about this, what are the literals we have corresponding, we can mark in the bottoms. So we have A dash, B dash, C dash, D dash. So that's easy to give the connection. Since here AND array is the fixed one, so we can't use the symbol of the logic array. So conventional symbol we are using here. So this first AND gate we are going to use for the A dash, B dash. So this is connected, this wire is connected to A dash, and this wire is connected to the B dash. Second one we are going to take for the B dash, D. So this wire is connected to B dash, and second wire is connected to D. So we have to put a small dot here so that it will be visible clearly that wire we are taking from where. Third AND gate is A dash, C, D dash. So now again here we have A dash, this is the C, and this one is the D dash. So once our function is fine from the K-map, then easily you can do this all implementation. So already we have taken the product terms of the F1. Now we have to take for the F2. So this product term is what here? B dash, C dash. So B dash, C dash. So B dash wire is connected here. This is the C dash. And third one and last product term for this, we have A dash, B, C, D dash. So here we have 4 literals. So we have 4 wires, A dash, B, C, and D dash. So now AND connections over. So this is the fixed AND array here. As per the logic of the PROM, we know that first stage we have fixed AND array that we have completed. Now second stage what we have here, we have programmable or array. So it is the programmable. So we are going to change as per our requirements, as per the user's requirements. So now already we have seen that how many OR gates are required. Since here we have 2 functions, so we have to take 2 OR gates. Now this one is going to represent the function F1, another is going to represent the function F2. So in case of F1, if you see that what are the product terms are there, corresponding AND gate output and this logic array wire we are going to mark as the cross. This cross shows the fuse is intact, so it is the logic 1 state. So for the function F1, we have A dash, B dash, B dash, D, and third one is A dash, C, D dash. So now F1 we have marked. Next we have for the function F2. So in case of F2 again, we have to mark it carefully. So for F2, what are the function we have? That product term is B dash, C dash, and second product term is A dash, B, C, D dash. So this both product terms we have marked here. So finally, this OR gate is going to give the function F1 and second OR gate is going to give the function F2. So here you have to decide how many AND gates are there. So that is we are getting from the product terms, and how many OR gates are there it is being decided how many functions are there. So we have to keep in mind that in case of PROM, we have fixed AND array the first section in the first stage, and we have programmable or array in the second stage. Like this, whatever function will be given, that can be implemented here with the help of AND array and the programmable or array. Thank you. Thank you very much.